Assalamualaikum and good day to everyone. In this video, we're going to have a look at one component system, the phase diagram of water and the phase diagram of carbon dioxide. One component system. It is a single component system that contains only one chemically independent species, maknanya dia ada one substance in the system. Example, water and carbon dioxide. It is a single component system which have three phases: solid, liquid, and vapor. Triple point and critical point. Most of substances, example water, can exist in three phases. Triple point. The temperature and pressure at which the three phases, solid, liquid, and vapor of a substance exist in equilibrium. Critical point. The critical temperature and critical pressure at which it is impossible to liquefy a gas. This is a phase diagram of water. The line in H2O phase diagram are similar as carbon dioxide phase diagram. The only difference at AB line, which the solid liquid boundary line for water slope to the left or has a negative slope. Water is liquid under normal condition at 25 degrees Celsius and 1 atm. At 1 atm, the phase changes from solid to liquid to gas or vice versa. The triple point of water A is below 1 atm, which is 0.00603 atm at 0.01 degrees Celsius. The critical point C is 374 degrees Celsius and 218 atm. The freezing point of water is 0 degrees Celsius at 1 atm and the boiling point is 100 degrees Celsius at 1 atm. The line AB slopes to the left because melting point and freezing point of liquid water decrease with pressure. An increase in pressure favors the formation of liquid, that is, the melting point is decreased by raising the temperature. Water behaves this way as ice is less dense than liquid water. Example 2. Consider a sample of water at point A. So A is the triple point. So the phase present ice, liquid, and water vapor. B. If the temperature of sample were reduced at constant pressure, what would happen? So let's say you reduce the temperature at constant pressure, the sample will freeze completely. How would you convert the sample to vapor without changing the temperature? You tak ubah the suhu. So macam mana you nak convert the sample to vapor? So you reduce the pressure to below the triple point value. This is a phase diagram of carbon dioxide. At A, triple point, at which the three phases exist in equilibrium, at negative 56.4 degrees Celsius and 5.11 atm. At critical point B, at 31.1 degrees Celsius and 72.8 atm. This point at which carbon dioxide gas cannot be liquefied. AB line is the boiling point curve, the variation of boiling temperature with pressure. Along AB, liquid carbon dioxide is in equilibrium with carbon dioxide gas. AC line is the sublimation or deposition curve, the variation of sublimation temperature with pressure. Along AC, solid carbon dioxide is in equilibrium with carbon dioxide gas. The triple point A, carbon dioxide, is above 1 atm. It is impossible for solid carbon dioxide to melt at 1 atm. Instead, solid carbon dioxide or dry ice sublimes into gas. AD line is the melting point or freezing point line, the variation of melting temperature with pressure. along AD, the solid carbon dioxide is in equilibrium with liquid carbon dioxide. AD slopes to the right or has a positive slope. This implies that the melting point increases with pressure due to solid carbon dioxide is denser than liquid carbon dioxide. Refer to the phase diagram of carbon dioxide below. Identify the temperature and pressure of point O, triple point, and C, critical point. At point O, temperature is negative 57 degrees Celsius and pressure is 5.1 atm. At point C, temperature is 31 degrees Celsius and pressure is 73 atm. Second, explain the variation of OD line, solid liquid boundary line with pressure. So OD slope to the right or has a positive slope. So the melting point increase when we increase the pressure. It's due to the solid carbon dioxide is denser than liquid carbon dioxide. Variation of melting point with pressure. An increase in pressure favors the formation of more dense phase. It's either solid yang akan jadi more dense phase ataupun liquid yang akan jadi more dense phase. When the solid is the more dense phase, the solid liquid equilibrium is inclined to the right. At higher pressure, the liquid is converted to solid. The solid becomes stable at temperature above the normal melting point or the melting point is raised by an increase in pressure. This behavior is shown by substance like carbon dioxide. So maknanya bila you increase the pressure, it will convert the liquid to the solid. So maksudnya they favor the formation of solid. So when the liquid is the more dense phase, the liquid solid line is inclined to the left. So an increase in pressure converts solid to liquid, maknanya they favor the formation of liquid. So the melting point will be decreased by raising the temperature. So water behaves this way as ice is less dense than liquid water. So what is the difference between water and carbon dioxide? Okay, the first one is effect of pressure and melting point. The melting point decreasing with pressure increase for water. And for carbon dioxide, the melting point increasing with pressure increase. Meanwhile, for the density of water, water more denser than ice, and for carbon dioxide, solid carbon dioxide more dense than liquid carbon dioxide.